If you have these problems, then you have to get them diagnosed and fixed right away before they cause major damage to your transmission and to your wallet. And if you want to get them fixed right the first time, then you're going to need to watch this whole video and not skip around. Every part of this video contains important details that could be the difference between buying a new transmission and just fixing a broken wire. I've already obviously done all the research for you. Now it's up to you to decide which person you want to be.
This general theory of a torque converter clutch: here's your engine, here's your flex plate, which is turned by the engine, and your torque converter is bolted directly to the flex plate. Then there's the transaxle. Here's a cutaway version of it. You can see where the studs are. When the engine turns, this whole thing turns, which is connected to the impeller. The impeller shoots automatic transmission fluid at the turbine. Turbine is directly connected to the transaxle here. Doesn't sound very efficient to you. It's not. So one way they try to increase the efficiency is by locking the two halves together with a clutch that pushes against here and locks the two halves together. If you look here, here's your oil pan here. It's got a valve body right here. The valve body is shown right here. This is filled with automatic transmission fluid, and this valve here, as it moves, will either apply or release the clutch. The valve is moved by the solenoid here, which is an electrical magnet. Right now it's blocking the flow of fluid because there's a spring in here pushing a ball shut.
It's off now, so no fluid pressure can come through here and reach the valve. The valve is being pushed shut by the spring here, and the pump is pressurizing the fluid. It's coming in through here, passing around here, through a hollow shaft in the transmission that goes to the torque converter and goes to the clutch and pushes it away. Also, fluid is coming from the pump again, around here, through here, and supplying the torque converter with fresh fluid. And majority of the heat actually comes from the torque converter, so that needs to be cooled. So it goes back through here, through a series of passages, and to the radiator, and starts all over again. Now when the power control module here sees, or the computer sees certain data, it's going to act just basically like a switch, connecting the battery here to the solenoid, which fires a magnet. This lifts up, bam, fluid can make it around here, down here, and to the valve here, pushing the valve just a little bit right there. And now what happens is the incoming fluid passes through here. All of it goes up through here and goes into here and pushes the clutch this way. The fluid around the clutch now gets drained out through here and it exhausts to the oil pan here. Of course, the fluid's still being cooled, so that still goes in just a very slightly different path. And all sorts of things can go wrong here. You could have a bad computer that could throw in bad codes. You could have a P043, that could be an electrical wire problem most likely. You could have a P1740. The computer actually monitors a solenoid, and if it's not moving, it could mean the solenoid is bad. You could have, like I did, a P1744. It's a mechanical stuck off. It means that it's detecting more than 100 RPM difference between the two sides. That could be a whole variety of problems. It could be a worn out clutch here. It could be something clogged over here or in here. Maybe the valve's not moving, it's stuck somehow. The other problem could be a P1742. It's mechanically stuck on. So this is actually stuck in here. It's detecting less than 20 RPM slip between the two halves when there should be more.
This is how you check your transmission fluid. Apply the parking brake. If the car has been running under a heavy load, it's going to need to cool for approximately 30 minutes with the engine off. After that, start the engine, flip the brake of course. Now shift through each gear while allowing it to engage. We'll do it slowly. Then put it back in the park, leave the engine running. With the engine still running, pull the dipstick out. Examine it for a color. It should be a dark red color like it is now. If it's brown and black, like it was in my case before I repaired the transaxle, then that could be an indication of clutch wear. If it's milky color, then there might be a coolant leak into the transmission. If it's aerated, like there's bubbles in here, that would be a sign of the transmission fluid has been overfilled, which can cause erratic control pressure on it. If it's burnt, the smell of it is burnt, that could also be an indication of a clutch or band failure. I would wipe it at this point with a clean white tissue paper and check for color again and look for little specks of wear material. Put it back in here. You're going to pull it back out, and I would look on both sides, because sometimes one side will get wet as it touches the side of the tube here, and it'll give you a false reading. So always check both sides to see which side is lower. And if the transmission has hit the proper operating temperature, then it should be between here and here, and that's where you're going to get the most accurate reading. If you're checking it while the transmission was cold, it's going to be between here and here. Alright, we're going to check the stall speed here. I have the emergency brake set, I've chalked the wheels, I have my left foot on the brake. I'm going to floor the accelerator. Let's see, it was about There are 4 clips and 4 screws. Apply the emergency brake, move the shifter around after you get the keys in, then these will pop right off. 2 of the screws came from here. This will pop right off. There you go. We're checking the Tcc Solenoid, the windings of the solenoid itself and the wiring. Pin 54, gray wire with a white stripe, that goes to the solenoid. And then we're going to a ground wire, which is 51, which is black wire with a yellow stripe. You can really do any black wire with a yellow stripe down here. And I've already removed the plastic cover. It pops right off. We're getting 20.2, and we can have a range of 13 to 27 ohms. Alright, this is a 4-speed transmission with a torque converter clutch, so you're going to should see 4 shifts in that case. And we're monitoring the activation of the clutch here. Once this goes about 13 volts, that means that the clutch solenoid is being activated. Here we go. There's 1. There's 2. There's 3. And number 4 is about to come up. There's 4 right there. You see the RPM dropped a little bit. Alright, now what we're going to do is we're going to go constant 50 miles per hour. And while I hold my foot onto the accelerator, I'm going to hit the brake. And you can see an RPM increase. Alright, here we're doing it now. You see that little RPM blip there? And you see the voltage. Now the voltage will come back on. Right there, the clutch is coming back on. And you're going to see a little RPM drop. I'm going to do it again. Alright, squeeze the clip, pull it off. Squeeze the clip, pull it off. Pop this here. Wiggle it back and forth. Come right off. Undo this, pull it off. Pull it off, set it aside. There you go. Pinch the clip, pull it back, pull this off. and then remove the bolts and the nuts, and then give it a little wiggle. And it should just come right off. Let me get you some more room. This is the transmission range switch. You need to pull that off. You squeeze the tab and you yank it off. There we go. There's a transmission control connector right below here that this big black wire is leading up to. You need to pull that off. Alright, this particular one, you have to lift up on it and pull up to get it off. Now we're checking between pin 54 and the ground. 10,260 ohms approximately, which is good. You're taking an ohm reading between pin 1 here and pin 54 to check the wiring harness. Alright, we've connected the cable directly to the positive side of the battery. And we need to be very careful not to touch the body or we're going to get a spark. And we're going to reach down and we're going to activate the solenoid manually. That's, if we're facing the front of the car, the upper left-hand one, okay? I think it's going to be the upper, it's going to be that left upper one we're going to touch. And then we'll hear a clicking noise. You hear that? I'm going to try to move my hand out of the way so you can see. That's the solenoid clicking. Good. See? And you can check the other solenoids too if you want to. There you go. If you're hoping for a more in-depth conclusion, click on the bottom video on the right, and that'll take you to part 2 where I give some more details on the valve body and some diagnostic resources for you. Alternatively, like, comment, and subscribe, or watch another one of my videos such as test an oxygen sensor with a multimeter, dissolve a broken drill bit from a hole, or how to make a bead in a piece of metal with a hammer instead of a bead roller. I hope you enjoyed.